Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome for another video about architecture. Architecture, as we have seen before, is one of the fundamental concepts of design. So why do we need architecture? We need to find answers or answer to these questions. The architecture actually is not the operational software, but a kind of representation which enables a software engineer to perform certain tasks like the analysis of the effectiveness of the design, consideration for architectural alternatives, and the reduction of risks that may be associated with the construction of the software or product as a whole. So why is architecture important? Architecture is important especially in representation of software architecture, and the architecture highlights early design decisions that will have a profound impact on all software engineering work. Architecture constitutes a relatively small intellectually graspable mode, that is, on how the system is structured and how its components work together. Architectural descriptions. IEEE proposed a recommendation on how to design and use an architecture. So this recommendation states that a conceptual framework and vocabulary for using during design of software architecture should be established. Detailed guidelines for representing an architectural description should also be provided. And another recommendation is a sound architectural design practices should also be encouraged. IEEE standard define an architectural description as a collection of products to document an architecture. So in this way, the description itself represents using multiple view, where a view is a representation of a whole system from the perspective of related set of concerns or intermediate stakeholder. Architectural genres. A genre implies a specific category within the overall software domain. That is, we may have a generic design for architecture, but in this kind of development or new way of designing things and creating architectures, we can have specific genre. For instance, within each category, like maybe we may have different genres, like in building, like databases, like hospital management, a lot of things. So for instance, within each category you can encounter a number of subcategories. For example, within the genre of buildings, you may come across the following styles like houses, condos, apartments, etc. So within each general style, more specific styles might apply. Each style would have a structure that can be described using a set of predictable patterns. Architectural styles. Each style describes a system category that encompasses four things. These are a set of components and set of connectors, constraints, and semantic models. For example, a set of components may include databases, computational models, while a set of connectors can be something that like a connector that connects the components, and constraints has to do with the definition of components that can be integrated to form the system. Semantic models enables a designer to understand overall properties of a system by analyzing the non-properties of the constituent parts. Although there are millions of styles that has been existing since 1960, but we have the following taxonomy of styles. These are data-centered architectures, data flow architectures, and call and return architectures, object-oriented architectures, and layered architectures. and we can see the design in the subsequent slides. So we see in this design, the central at the center is a kind of repository, that is data-centered architecture, where various clients are connected and they are having access to the database and vice versa. So the data flow architecture is a little like this, where a data is being transformed at different stages. At any stage, the stage is called a filter. Then the connector that connects each filter is called pipes. So we can have this kind of structure as pipes and filters. Sometimes if the structure is like linear, something that has to do with in this form, for instance, we have like one filter, then we have another filter like this, then the connector between this and this kind of structure is called batch sequential, because everything is in linear, so data is being transformed in a linear form. So maybe this one is filter 1, and this one 2, and this one 3, then this one is connector, this pipe, this connector, then another pipe here. So, and we have another architectural structure which is called and return. So in this, this is example of main and subprogram, where the main program is calling open this subprogram, and the subprogram itself may call from another subprogram. So that is how the flow is looking like a tree structure. So, and we have another structure which is layered architecture. This also we have like different layers. At the outer layer is the user interface that is responsible to connect, and here in boxes, rectangular boxes are the components in each layer. So here is the application layer, and the inner is the core layer, which is the like operating system, and this is the utility layer. So architectural patterns. Architectural patterns, as we have seen and discussed earlier, is a kind of the advantage of these patterns is to find a solution which can be applied in the recurring problems. So in this, we need to consider these factors like concurrency. Application must handle multiple tasks in a manner that simulates parallelism. Then we have persistence, and this has to do with persistency in a database, for instance, database management system, application level persistence, and we have distribution. Distribution is the manner in which system or components within the system communicate with one another in a distributed environment. Then under it, we can have a broker which acts as a middleman or intermediary between a client component and a server component. So this slide is showing us architectural design. The software must be placed into a context. That is, the design should define the external entities, something like other systems that are interacting with the component or the architecture, devices, people. Then a set of architectural archetypes should also be identified. Here, an archetype is an abstraction which is similar to a class, but it represents one element of the behavior. The designer specifies the structure of the system by defining and refining software components that implement each archetype. So as we can see diagrammatically, this is architectural context from the example safe home example. So here you can see we have a control panel, here we have a home owner, and we have the safe home product. So this is internet-based system, and this at the middle is the target system, that is security function. This is surveillance functions, and we have sensors. So this is the architecture context. So that's why we said the context of the architecture should be identified and provided. So an archetype from this example can be derived in this form, like maybe the controller, which is responsible to control what is happening, for instance, maybe alarming or disalarming, and the node can be identified also as an archetype, like detector and the indicator. So component structure can be in this form, where we have one component is connected to another component that is home, home executive, which extend the communication management, which also have sub-components. Here we also have different components connected to the main component. So the previous component can be defined in this form. And for each architecture design or architectural design, we need to consider certain factors. They are very important. For instance, the economy. That is the best software is uncultured. It means that the software should get rid of some extra things that are not necessary. So this will have to economize the way the architecture is designed, and we have visibility. Architectural decision and reason for them should be obvious, especially to engineer or software engineer who examine the model at a later time. And from this it goes to the next, that is implementation. And then we have spacing, that is separation of concern, to make things easier, like in a modular form. In a design without introducing hidden dependency is a very good design. And the symmetry is talking about the consistency in the architecture. That is, architectural symmetry implies that the system is consistent and balanced in its attributes. Then the emergency is trying to show that the architecture is flexible enough in case of any evolvement in the future, because now we are in an agile development where things evolve without notice. So the design should be elegant enough and flexible enough to enable this kind of changes in case of new things emerge. So consideration, we have architectural decision documentation. With this we have to consider this, determine number one, determine which information items are needed for each decision. Number two, defines links between each decision and appropriate requirements. Provide mechanism to change status when alternative decisions are to be evaluated. Define prerequisite relationships among decisions to support traceability. Link significant decision to architectural views resulting from decision. Document and communicate all decisions as they are made. Then architectural trade-off analysis. In this case, we have to consider the collected scenarios. Then we move to elicit the requirements, constraint and environments. Then describe the architectural styles. We have to evaluate the quality attributes. Then identify sensitivity of the quality attributes. Then critique candidate architecture. Architectural complexity, because we don't have much time, we have to rush. So in this, it is the overall complexity of a proposed architecture is assessed by considering dependencies. In this case, we have three main dependencies: sharing dependencies and flow dependencies, then constraint dependencies. For sharing dependencies, it has to do with representation of dependence relationship among consumers who use the same resources or producers who produce for the same consumers. For flow dependencies, it represents dependence relationship between the producers and the consumers of resources. Constraint dependencies is representation of constraints on the relative flow of control among a set of activities. Here comes the end of this video. Thank you for listening, and we'll see you next.